Hello students, here is the question. Here we have a question. Now this is a lengthy question. Let me just pull up the diagram so that I can understand that to you better. If a is greater than 0, so we have a condition on a, then the feet of perpendiculars from the point A and B, we have put some points over here, and these points have a feet of perpendicular on the plane represented by Lx plus My plus Nz as C and D. Now C's coordinates are known to us, and D we need to find out because we need to find the length of the line segment CD. So what we are going to be doing is we first need to find the equation of the plane, correct? Because if we find out the equation of the plane, we can put the point distance of B from this formula over there and get the coordinates of the point D. And for that we first need to find the direction of cosines for the plane. And how are we going to find that out is we have A and we have C in terms of A, the constant. So what we are going to do is we are going to subtract these two coordinates from each other, get the common point that we have, we multiply it by lambda, some factor that we get. There need not be any reason to consider AC as the only normal in this case. There AC could be having variable length over here depending on the value of lambda and value of A. So what we will do is we will consider the direction of cosines of plane that we consider over here lambda, the direction cosines of line AC. This is the factor that will decide what length of AC that we are considering, and the direction cosines of plane will be coordinates of A minus coordinates of C. So we get the difference. For x coordinate as A, we multiply that with lambda. For y coordinate, we get that to be minus A, we multiply with lambda again. And for the z coordinate, we get the difference as 4, we multiply that with lambda. So this is the equation or the direction of AC having a variable length which we don't know. So the equation of the plane is, we have the direction cosines. If we just remove the lambda from this case, we can get the common point in this, that is the point that we can take over here, and this is ax minus ay plus 4z is equal to 0. Now the coefficients over here is the direction of the normal in this case. So we know that point C lies on the plane. After getting the equation of the plane, we put the point C into the plane and get the value of A is equals to plus or minus 2. Now we know the condition given to us is A should be greater than 0. So we take A is equals to plus 2. The minus 2 value is discarded. So the plane of the equation of the plane becomes 2x minus 2y plus 4z is equals to 0. The point C is this. We also have the point A in this case, and then we need to find the coordinates of D. So how are we going to do that? We are going to be using the equation for the line and the distance from the point formula. So the equation of the line given, we have a point is x minus 0. Here we substitute the point called a point B. As you can see, I just marked that. We have x minus 0, the x coordinate of B, upon 2 normal the normal direction for the x part. There we have a y minus 4, the y coordinate for B, and the normal direction for the y part minus 2, as we got over here, a minus a and 4. And 4 we put over here the direction for the z part of the plane, and we have the z coordinate of B, which is 5. And when we get this is equal to the distance of the plane to the point, which we write that is, we put the point in the equation of the plane, that is B in the equation of the plane. We divide that with the squares of the direction cosines of the planes, which is 2 square plus 2 square plus 4 square. 2 square we write here is minus 2 the whole square, minus 1 square becomes 1. So we write 2 square over here, and when we solve this and put each of these values to be equal to this and this, we get the x, y and z coordinate, which is equal to minus 1, 5 and 3. And so CD is just the distance formula that we use to get the value of CD as root 66 units. Thank you.